Welcome back, guys. Moving on to the next question. So we have to simplify both of these and state the restrictions. So starting off with number 1, we've got 4x plus 5y over 6 minus x minus 3y over 4. So first thing you do, factor. Notice that everything is factored. Can't really factor anything in either numerators or either denominators. Then you want to state the restrictions. But because there's no variables in the denominators here, there actually is no restrictions for this one. Right? There's no variables. Like here we have these x's, so there's probably going to be restrictions there. But here, because we have numbers, there are no restrictions. And then you just simply want to simplify it. So we're subtracting rational expressions, fractions. What's the lowest common denominator between 6 and 4? 12. So this, we have to multiply by 2 to get 12, so we've got to multiply the top by 2. But the 2 has to multiply by that whole bracket, like that. Then this here, we've got to multiply by 3. Top we have to multiply by 3. So we'd be subtracting 3, and then we'd be multiplying by x minus 3y. You got to make sure that when there's a negative here, you're distributing in that whole bracket there. Just be aware of that. And then from here, you just want to simplify. So 8x minus 3x, that would give us 5x. Then we'd have 10y plus 9y, which would give us 19y. All over 12. So that's what it simplifies to, and there are no restrictions. Let me just double check. Yeah, seems right. Okay, number 2. First step you want to do, factor. Can't factor, can't factor, can't factor. Here, this could factor. So 5x over x plus 1 minus x minus 3 all over, what would x squared minus 4x minus 5 factor to? That would be x minus 5x plus 1 when you do decomposition. You could do it on the side here. If you can't do it right away, automatically, just do the factoring on the side and then bring it back over here. So, factored everything. Now we want to state restrictions. Notice x plus 1 can't equal 0, which means x cannot equal negative 1. And then here, x minus 5 cannot equal 0, which means x cannot equal positive 5. I'm going to write these up here, actually, just to give myself some more room on the whiteboard in case I need it. And then from here, you simply subtract these rational expressions. So we're simplifying. So what's the lowest common denominator going to be? Well, notice that x plus 1 is common in both. And then this factor is not common in both, but it's still a factor that's different than x plus 1, so we're going to have to include it. So what do we have to multiply x plus 1 to get this lowest common denominator? We've got to multiply it by x minus 5, which means we have to multiply the top by x minus 5. And then over here, this is already the lowest common denominator, so this x minus 3 we would just keep the same. So we would write 5x, x minus 5, and then subtract that whole term, but that whole term is in brackets, as I mentioned here. When you're subtracting this, if this is 2 terms, got to make sure you put them in brackets, or even if it's 3 terms, 2 or greater, got to put that in brackets. So then you're going to have to distribute that negative inside the bracket. So when we distribute this 5x here, we'll have 5x squared minus 25x minus x plus 3 all over that denominator of x plus 1, x minus 5. And then negative 25x minus x, those are like terms. So that simplifies to 5x squared minus 26x plus 3 all over x plus 1, x minus 5. And when you get to this step, as I mentioned in the lecture videos a bunch of times, we also did examples where it simplifies further. You got to check if you could factor that numerator. And notice that we can't factor it. 5 times 3 is 15. And then the b value is negative 26. There's no two numbers that multiply to 15 add up to negative 26. So we can't factor that any further. So that is the simplified expression. But you do have to check if it could factor further, because sometimes this simplified numerator is going to factor, and then there's going to be further cancellation that can happen. Like, let's pretend this numerator was able to factor to x plus 1 and then x minus 4. The x plus 1s would cancel out and we'd just be left with x minus 4 over x minus 5. Right? So if you just left it like that, that would be wrong. So always check if you could further simplify, further factor that remaining numerator.